Okay, so we're going to be dividing polynomials in two different ways. Okay, we're going to first of all look at polynomial long division, which will always work. No matter what you're trying to divide, it'll always work. Then we're going to look at what's known as synthetic division. That will only work in certain circumstances. That only works when you're dividing by a linear polynomial. Okay? Now, in this case, we are dividing by a linear polynomial. We have x to the fourth minus 10x squared minus 2x plus 4 divided by this binomial x plus 3. Okay? Now, this is a process you've probably done in the past, but even if you have done, it's easy to forget. Okay? So, let's start out first of all by writing out the problem. And when we do this, we need to be careful because what do you notice about this polynomial that we're dividing? What's it missing?
X cubed.
It's missing an x cubed term. When you write this out, you need to make sure that you account for that with a placeholder. So we had 0 x cubes in our original polynomial. So x to the fourth plus 0x cubed minus 10x squared minus 2x plus 4 is being divided by x plus 3. Okay? Got to make sure you have that placeholder. Now, when you're dividing, the only thing that you really have to look at when you're figuring out what to divide is the first term here and the first term here. The rest of it will just kind of take care of itself as you work through the process. Okay? So, what is x to the fourth divided by x? It's x to the third. So, I'm going to, in order to keep my powers of x aligned up, I'm going to put that x to the third right here. Then we multiply. X to the third times x is x to the fourth. X to the third times 3 is a plus 3x to the third. Notice here's why we needed to put in that placeholder of 0x cubed. Okay, because just because our original polynomial didn't have one doesn't mean that we won't run into them somewhere in the problem. Okay? Now, what do we do with those values?
Subtract.
That's right, we subtract them, okay? So we are going to subtract x to the fourth and subtract the 3x cubed. And, as a result, notice our x to the fourths cancel out to 0. If that does not happen, you did something wrong, okay? You've got to make that cancel out to 0, or else you did something wrong. So that's 0 like it's supposed to be. 0x cubed minus 3x cubed is a negative 3x cubed. Okay? Now we bring down. We bring down our next term, so we have a minus 10x squared. Okay? So we're done with our first step. Got a couple more to go. So, now, all we care about, because we're about to divide again, all we care about is this minus 3x cubed divided by x. So what's minus 3x cubed divided by x? There we go, a minus 3x squared. And I'm going to put that over my other x squared term. Okay? So, again, we multiply. Negative 3x squared times x is a minus 3x cubed. Negative 3x squared times 3 is a minus 9x squared. Okay? And what do we do with that? We subtract it, okay? So minus a negative 3x cubed is plus 3x cubed. minus a negative 9x squared is a plus 9x squared. And again, just like it's supposed to, this first term should cancel out to 0. So we have 0x cubed, but we have a minus 1x squared. Okay? And then, again, we'll bring down our next term. So minus x squared minus 2x. Okay? So now for our next part. All we care about is the minus x squared divided by x. What's minus x squared divided by x? Minus x. We multiply it back. So we have a minus x squared. Minus 3x. There we go. And then what do we do with that? We subtract again. Okay, hopefully you're getting the process here. Alright, it's repetitive. It does the same thing over and over again. So again, this cancels out to 0. Negative 2x plus 3x is a positive x. And now we bring down the 4. Okay? Now watch this. I know this is going to be my last step because look, these have the same power of x. If you get to the point where this power of x down here is smaller than this power of x up here, like if we were dividing by an x squared plus 3 or something, we would stop and just write it as a remainder. Okay? But right now they're equal, so we need to do one more step. So x divided by x is a plus 1. We multiply, and we get an x plus 3, and we subtract. Okay? So that's 0 like it's supposed to be. 4 minus 3 is 1, and that's our remainder. Okay? I'll put a little r there. That's our remainder. And notice that 1 is still in this big division box, right? So that 1 is still being divided by the x plus 3. So we need to put that as a plus 1 over x plus 3. There's our remainder. Okay? Is this process coming back to memory?
Yeah.
There are a few little details that are easy to forget, like putting the placeholder in and stuff. So that's why I wanted to make sure we go through it. Okay? Is there anyone that this is the first time you've ever seen this? Good. Good. All right. Now, I want to stop for a moment and just make sure we understand what this is telling us. This is telling us a couple of things. First of all, I know that this polynomial, x to the 4th minus 10x squared minus 2x plus 4 equals x plus 3 times all of this. X cubed minus 3x squared minus x plus 1 plus 1 over x plus 3. Okay? So, division like this is one way of factoring out a polynomial, right? Now, it wasn't particularly useful in this case because we got a remainder. Alright? What if we had not gotten a remainder? What would that have told us about this polynomial function, the original polynomial function? Okay? We could have like kept factoring and tried to find more stuff.
If there wasn't a remainder, it would mean that what you're dividing by is a factor of the polynomial.
Okay, it is a factor of the polynomial, and that would mean what about?
Would that be like a 0 or something?
Good, what would be a 0?
X equals -3.
Exactly. If this came out to a remainder of 0 instead of what it did, then -3 would have been one of the zeros of our function. Okay? Now in this case it's not, but watch out for that. And if you know one of the zeros, then you can divide and you better get a remainder of 0. Okay? But when you divide, that'll help you get something like from down to x to the 4th to maybe something that you can then factor. Okay, and we'll be doing that on Monday. Okay? So, now that you've seen one and your memory has been jogged a little bit, okay, let's try one. Notice here we're missing a few terms, so we need a couple of placeholders, right?
Yeah.
So let's write it out. 7x cubed, we're going to have a 0x squared, a 0x, and a plus 3, and we're dividing this whole thing by x plus 2, okay? So take a couple minutes here and try the division, okay? And if you're stuck, let me know and I'll help you. If you're watching the video, I can't pause, you might want to skip a little. Need an eraser. Okay, so that's good so far. So you got a remainder.
Oh, so
So
I
you just,
remember.
yeah, make sure you put your remainder up in your answer once you get to the end. Yes. The only time you'd have to be careful is if you were dividing by like an x squared, which we'll see next example, you would have you might have like a 2x minus 53. So if you put the negative, remember it would apply to both things in the numerator. So all right. so this is what you should get. Number that I saw already had this. That was good. Okay. You can see here why the placeholders are helpful. All right. Also, as you write your answer, I encourage you put the squared parts over the square parts, the x parts over the x's, and so on. That way it's really obvious once you've gotten to the end and you know where your remainder is. Okay? Alright? Is anyone not able to get that or have a question about how we got that? Alright, good. Good. Now, we don't only need placeholders in what we would call our dividend. That's the thing that you're dividing by something else. Okay? But if we had something like this, we would also need to make sure that we included placeholders in what we were dividing by. Alright? Another thing too, is we look at this example here, is you'll notice the terms in what we're dividing are all mixed up. Okay? So, the first thing that I would want to do if I were approaching this problem is to write the terms here in decreasing degree. So I would put my 6x cubed first, plus the 10x squared, plus the x, plus the 8. Now I have all the powers of x accounted for from the cube all the way down to my constant, so I don't need any placeholders there. But it would be helpful to go ahead and write this out as 2x squared plus 0x plus 1. Okay? So, now, let's actually work through the division. Okay? What am I going to have first up here?
3x.
A 3x, right? Because x cubed divided by x squared will give me an x. So notice, there's where my first part of the answer is going to go. It's just a 3x. Now as I multiply it back together, I have a 6x cubed. I have a 0x squared. And I have a plus 3x that I then need to subtract. That cancels out to 0. Notice here's where that placeholder is helpful because it helps me line up my terms. 10x squared minus 0x squared is 10x squared. And x minus 3x is a minus 2x. Okay? Now we need to divide that part. And actually, I almost forgot. I'm going to bring down my 8. So I have this plus 8. Okay? Now I need to divide this part by the 2x squared plus 1. Alright? So what's going to go up here?
5.
Just a 5. So plus 5. And when I multiply it, 5 times 2x squared is 10x squared. Plus a 0x plus 5, and I do the subtraction, I'm going to get a minus 2x plus 8, or I'm sorry, plus 3. 8 minus 5. Okay? Now notice I'm done with the division. Why do I know I'm done with the division?
This one's smaller than the 3x squared. No, yeah, it's smaller than 3x squared plus 1.
Okay, we have the 2x squared, and its exponent is more than the exponent we have now. Alright? So once you get down here and this exponent's smaller than what you're dividing by, you can write your remainder. Okay? So, we would say plus a negative 2x plus 3 over
2x squared.
2x squared plus 1. We can get rid of the placeholder now. Okay? Now, one thing to be very, very careful about is sometimes people will do everything perfectly. They get to the end and they do this. They say 3x plus 5 minus 2x plus 3 over 2x squared plus 1. And what would the problem with writing your answer that way be?
It's missing like the 2x plus 1 multiply.
Oh, you're saying the factored form.
Yes.
Yeah, we could write it in the factored form, 2x squared plus 1 times that. That is correct. But what's wrong with what's in the parentheses here? Alexi?
You're making the entire fraction negative instead of just the remainder.
Okay, and instead of just this, remember it was just a minus 2x.
Yeah.
But the 3 was positive. If you put the minus in front of the fraction, it's going to make the 3 negative as well. Okay? So now, can you do this? Yes. However, you would need to change this so that it would end up being a plus 3. So you'd need to change it to a minus 3. Does that make sense?
Yes.
Okay? Personally, just to be safe, I always just put plus and then put what I got from my remainder in there. Okay? So be careful with your signs when your remainder has more than one term. Okay? All right, are there any questions in this yet? Okay, so when we're dividing by some kind of a polynomial that has a degree bigger than 1, we're going to have to use polynomial long division. Okay? However, when we're dealing with ones like this, where we're dividing by a linear, an x plus 3, or this one where we're dividing by a linear x plus 2, we can use what's known as synthetic division. Okay? So, let's look at how we would deal with this with synthetic division. Alright, let's look at the process. The first thing I want you to understand is, you'll notice here they have to divide ax cubed plus bx squared plus cx plus d by x minus k. We're going to follow this algorithm here. Okay? Notice the x minus k. This is probably the easiest thing to mess up, okay? It's similar to when we were finding zeros after we factored. If this was our factor, x plus 3, what would the 0 be? A negative 3, right? So you got to kind of think of this in terms of it's what are we subtracting? We would have to subtract a negative 3 in order to get x plus 3. Okay? So that's helpful because we got to identify k correctly or else the whole thing gets messed up. Alright? So now we're going to put that negative 3 over here just to remind us what number we're working with. The next thing I'm going to write down, you don't have to write down, okay? But I like to show this to you just so we understand a little bit better how this process works. Our columns above this line are the powers of x that we currently have. We have an x to the 4th, we need an x cubed, we have an x squared, an x, and then we have a constant, some number. Alright? when I'm dividing by x to the first, what's going to happen to all those powers?
Decrease by 1.
They're going to decrease by 1. So whatever number I get down here is going to be for my x cubed. Alright, because x to the fourth divided by x is an x cubed. And then this is going to give me my x squared. And this is going to give me my x. This column is going to give me my constant. And then if I already had a constant, that's where my remainder is going to come from. Okay? Now you don't have to write this out, but I want you to understand this so that you know how to interpret your answer at the end a little bit better. Okay? So, how does this whole process work? First of all, notice here it says we're going to put A, B, C, and D across the top. Well, A, B, C, and D are the coefficients of our powers of x. So we had 1x to the fourth. We didn't have any x cubes. We had a minus 10x squared, a minus 2x, and then our constant was a positive 4. Okay? Then, here's kind of the mantra you need to repeat to yourself. We're going to add down, multiply over. Add down, multiply over. Add down, multiply over. And keep doing that. So, if we do 1 plus 0, we get 1. So we just added down. Now we're going to multiply over. So what are we going to multiply by?
0.
We're going to multiply by, here's where the k comes in. Notice here it says a is here. This is k times a. Alright? So that's where we're multiplying over. So times a negative 3. 1 times negative 3 is negative 3. Okay? So we added down, we multiplied over. So now we're going to add down. 0 plus negative 3 is negative 3. And then we multiply over. So times a negative 3 is a positive 9. Now we're going to add down. So we get negative 1. And then we multiply over. So we get a 3. Then we add down. And then we multiply over. And then we add down again. Okay? And when you don't have anything more, when you run out of columns, you're done. Okay? So you add down, multiply over every time. Oh, you need to do that again? Go ahead. You can. It's okay. All right, so look, now interpreting our answer, you know, just having a bunch of random numbers that we have no clue what they are doesn't really help us. Okay? We need to know what those stand for. So this is a 1x cubed minus 3x squared minus x plus 1 plus, what's this going to go over? It's going to be 1 over the x plus 3. Okay? Alright, so that's how we would then do the synthetic division. Alright? There was one other example I was going to work on where we had a coefficient in front of the x. Okay? I think there's one in your independent practice that's like that. Take a look at the website. I'll include an example of that on the website for you to look at. Okay? Alright. Have a great day.